In this video, we'll be discussing about merge sort. So merge sort is one of the important sorting techniques in which a given array is divided into two parts and according to their position in the array. The elements are divided on the basis of position in which they are present in the array. So if the number of elements is 1, then you can directly sort it. But then if n is greater than 1, we need to split it into equal halves. Say A array will be split into B and C. A would be split into B and C and sort them recursively and finally merge them. So that is what merge sort says. So it is a perfect example of successful application of divide and conquer technique. So we make use of divide and conquer here because initially we are dividing it, then we are conquering it, that is finding the solution, sorted one in the subarray, and then we are combining it. So that's what divide and conquer technique speaks of, right? So yeah, that is one thing. And if we have an array of 0 to n minus n elements, so this would be split into two parts. That is, from one part would be b of n by 2 minus 1, that is middle element, from 0 to half, first half, then the other half will be stored in C. So let's take an example to understand this. So if I have 8, 3, 2, 9, 7, 1, 5 and 4. Suppose these are the elements of array A. And I need to sort this using merge sort. So initially how many elements are there here? I have 0, 1, 2, 3, 4, 5, 6 and 7. Totally there are 8 elements. When there are 8 elements, if I do the floor division of n by 2, that is 8 by 2, I get 4, right? 4. So I will split the array from 0 to 4 and from 4 to 7. Okay, so that's how we'll be doing it. 1, 2, 3, 4. 4 elements one side, another 4 elements on the other side. So I will get B as 8, 3, 2 and 9, right? I've divided this. And on this side, I'll get C as 7, 1, 5 and 4. Further, if I split this, I will get 8 and 3 here. And on this side, I'll get 2 and 9. Here, if I further divide it, I'll get 7 and 1 here. And on this side, I'll get 5 and 4. Further, if I divide these two, I would be left with 8 and 3. And on this side, I'll have 2 and 9 here. Here I have 7 and here I have 1. Here I have 5 and here I have 4. So this was about the merge part, your dividing part. Now I'll quickly merge it, okay. So in order to merge it, out of these two would be merged in a sorted order. So I'll have, when I'm merging these two, I will get 3 and 8 here. When I merge these two, I would get 2 and 9 as it is because they are in merge like proper order. If I merge these two, I get 1 and 7 here. When I merge these two, I would get 4 and 5 here. Further merging these two, I would get 2 being the smallest first, then 3, then 8 and then 9. If I merge these two, I would get 1, 4, 5 and 7. And finally, when I merge these two, so this is B and this is C, sorted B and C. So that is what we decided in divide and conquer, right? First we divided, this is the conquering part, and then we combine it. One important thing to remember for merge sort is that we are dividing the elements on the basis of the position in the array, okay? So B and C, if I merge, I will get 1, 2, 3, 4, 5, 7, 8 and 9 as the sorted array. So this is the output. Okay, so finally I'll get this as the output. Now let's look into the algorithm part. So we'll discuss the algorithm first. So we have two algorithms here. One is to split and the other one is to merge. Okay, so the first algorithm is algorithm merge sort. So we are taking an array, sort array A by recursive arrangement. So input is the array which we are taking, output is the sorted array. In order to get this, first n value should be greater than 1. That is what we have discussed here, right? So if there is only one element in the array, then it is sorted itself. No, you need not perform merge sort on it. So yeah, and if n is greater than 1, so if n is greater than 1, all these would be considered. Copy A of 0 to n by 2 minus 1. That's what we have done here, right? We did the floor division and copied 0 to n by 2 minus 1. Here 4 came, right? 4 minus 1 is 3. So from 0 to third position, we have taken it, copied it and pasted it to B. And similarly, n by 2. N by 2 value is 4 by 2. That is 8 by 2. That is 4. From 4 to n minus 1. 8 minus 1 is 7. From 4 to 7, we have copied it to C. So these two steps we have executed here, B and C. Next, we will apply merge sort for B. So for B, again you take it and again do floor division and again split it. Okay, so that's how we have done and reached this part, right? And for C also we have done and reached to this part. Next we will call merge BC. We are considering array subarray B, subarray C, and merging it in A, array A. Okay, that's where we get the final, that is the proper sorted output, right? So sorted array, right? So that is about this. So merging of two sorted arrays. So here we'll be looking into the merge algorithm. So in this we'll be taking two subarrays, that is B and C, and then combine it and give the proper output as A. So input is B and C, both are sorted, and output is A, sorted array, which we'll give. I, J, K, we are taking it as 0. I should be less than P, J should be less than Q. P and Q are the like 0 to P. Okay, this n by 2 minus 1 is taken as P, and this n minus 1 is taken as Q. Okay, the last elements of both the subarrays. Then this condition, if B of I should be less than or equal to C of J, if this is satisfied, then the B of I value would be stored in A and I value would get incremented. Else, the C of J value would be stored in A of K and the J value would be incremented. With these two, even the K value will also be incremented. When the 0, it reaches to the point P, that is, we keep on iterating and we reach the end point. At that time, we copy all the contents of C to A, else we copy the contents of B to A. We'll understand this better while solving a problem. So let's look into an example. Let me write the example here. This is merge sort example. So I'll take an array of elements 8, 12, 15, 7, 10 and 17. I'll write the indexing. There are totally 6 elements here. So initially this part, we'll look into this part. N is greater than 1. Yes, n is greater than 1. Next, copy 0 to n by 2 minus 1. N by 2 minus 1 here is n by 2. What is n by 2 value? N is 6. 6 by 2 is 3. So 3 minus 1. 3 minus 1 is 2. That is from index 0 to 2. I'll write it in B part. So I'll write B as 8, 12 and 15. So this line. Next we have copy n by 2 minus n by 2 to n minus 1. N by 2 is this part, right? That is 3. 3 to n minus 1, I'll copy it in C. Okay. 7, 10 and 17. Here I'll be taking the total elements. The total elements in B are 3, right? So P is equal to 3. And the total elements in C are 3. So 3 I'll write here. I'll write the indexing 0, 1, 2, 0, 1, 2 here. And I will allot I to B and C to J and J to C. Along with that, in order to write the sorted array, I'll make use of K. Okay. So initially, so this part, we are done with this part, that is splitting. Now let's look into this part, the merging part. So initially I'll be taking I is 0, J is 0 and K is 0. So next I have this condition while I less than P and J less than Q do. I'll check this. So while this is satisfied, I'll check this. I value is 0. Initially I value I've taken as 0. No, 0 less than 3 and 0 less than 3. Q value is also 3. So this is satisfied. I'll look into the inner part now. Inner part I have, if B of I is less than equal to C of J. B of I less than equal to C of J. What is B of I value? B of 0 less than equal to C of 0. What is B of 0? B of 0 is 8. 8 is less than equal to 7. No, this is false, right? When this is false, I'll go to the else part. That is, C of J value should be updated to A of K. C of J. What is C of J here? 7. C of J value should be updated to A of K. A of K. A K value is 0 initially I've taken. No, so A of 0. That is, in A of 0, I will store 7. Okay, so 7 here I'll store 0, 1, 2, 3, 4 and 5. So 7 I've stored in the array. So I'm done with sorting the first smallest element. Done. After this, because I have stored the j value here, I have to increment j is equal to j plus 1 and k is equal to k plus 1. So irrespective of if this is implemented or this is implemented, k will increment automatically. Along with that, I or j would increment depending on the cases. So here c of j was considered. So j I'll increment and k I'll increment. So I'll have 0, j I'll have 1 and k I'll have 1. Now again 1 is less than 3 and here 0 is less than 3 and 1 is less than 3. Do I can check inside, that is b of I. What is b of I here? B of 0 is less than equal to C of 1. C of j, no, C of 1. Check if this is true. B of 0, what do I have? B of 0 is 8. 8 is less than equal to 10. True. When this condition is satisfied, I'll update in A of 1. A of k, no. A of k place in place of A of k, I should update B of j. That is, in A of 1, I'll be storing the value of B of 0. That is, in A of 1, I'll be storing the value of 8. So 7, after 7, I'll write 8. So here, because I've stored B of I, because I've stored I value here, I'll increment I is equal to I plus 1 and k is equal to k plus 1 as it is. So next here I have I value as 1, j value as 1 and k value as 2. Now again I'll check 1 is less than 3 and 1 is less than 3. Do this while loop satisfied. Now b of 1 less than equal to c of 1. B of 1 is 12 less than equal to c of 1. C of 1 is 10. No, this is false. When this is false, c of j value should be updated in a of k. A of k, in place of a of k, c of j value will be stored. A of k is a of 2. I'll store c of j. C of j is 1. C of 1. So c of 1 value is what? C of 1 value is 10. So in a of 2, 10 would be stored. So I'll write 10 here. Next, now that because I have here j value is being stored, I'll increment j is equal to j plus 1 and k is equal to k plus 1. Now here I'll have I is equal to 1, j is equal to 2 and k is equal to 3. Right, k value is 3. Now 1 is less than 3 and 2 is less than 3. True. I'll look into the inner part. B of I. B of I. B of I is 1. B of 1. B of 1 value I have is 12. 12 is less than equal to C of j. C of j is 2. C of 2 is 17. 12 is less than 17. Yes, this condition is satisfied. When this condition is satisfied, A of k, in place of A of k, I should store B of I. What is A of k here? A of 3, I will be storing B of I. B of I is B of 1. Okay, what is B of 1 value? That is 12. 12 would be stored in A of 3. So I store 12 here. Okay, next, because I have stored the I value, I'll increment I is equal to I plus 1 and k is equal to k plus 1. Next, I have here I is equal to 2, j is equal to 2 and k is equal to 4. K is equal to 4. Next, I have 2 is less than 3 and 2 is less than 3. True, both are satisfied. No, so true I'll write. Now, B of 2 should be less than or equal to C of 2. B of 2, what is B of 2 here? 15 less than equal to C of 2, 17. This is true. When this is true, in place of A of k, I will store B of I value. What is B of I value here? 17. And k value is A of 4. So in A of 4 position, I'll be storing 17. So I'll write 17 here. No, sorry, 15 is less than, no. So 15 here. So I'll write 15 here. Next. So here I value will get incremented and k value will get incremented. So now I have I is equal to 3, j is equal to 2 and k is equal to 5. Next, I'll look into this condition, I less than p. But here 3 less than 3, this is failing, no. So when we come across this case, or I can say that I've reached this point, that is I is equal to p, that is 3 is equal to 3. In this case, whatever the contents of C are there should be stored in A. So this is stored already, done, this is stored, this is stored, this is stored, this is stored. Whatever the left contents, remaining contents are there in C should be stored in A, that is 17. I have stored 17. So this is how the merge and merge sort algorithm works. I hope you have understood all the steps till here. So here we are copying contents of C to A, the remaining ones. So I hope you have understood the algorithm. So merge sort and merge algorithm. Now let's write the analysis part here. So initially we have to note down the recurrence relation here, right? Recurrence relation can be written as C of n is equal to 2 times C of n by 2 plus C of merge of n. I'll explain this why we have written 2 times C of n by 2. Because if you look at here, the given array is being split twice, no? Because it is B part we are splitting it once and C part we are splitting it again. N by 2 we are doing, no? Giving size, if the array is of 10 elements, then 5 elements here, 5 elements here. 2 smaller sorted arrays we are obtaining. Along with that, we are also doing the merge part here. So this merge part n. So that's how I have obtained 2C n by 2 plus C merge of n. This is only applicable when n value is greater than 1. So if n value is equal to 1, what will I do? So if n value is equal to 1, C of n would directly be 0. Because if there's only one element, what will I sort? There's nothing to sort, right? So in this condition, we'll be writing the worst case scenario here. So worst case scenario, I would obtain for C merge, it would be 2 times C, sorry, this is C of n, C worst of n. You can write 2 times C of n by 2 plus n minus 1. Okay, n minus 1 here because here n minus 1 times we are iterating through the given array, right? So that's why n minus 1 I have written here. So now that we have obtained the recurrence relation for both the worst cases, so C worst of, I'll also write the C worst of 1 would be 0 if there's one element, right? Now let's solve this using substitution method. So I have two relations here. T of n is equal to 0 if n value is 1, yes, and the other relation I have is 2t n by 2 plus C of n. This is when n is greater than 1. So till here we have understood, right? Next, let's proceed further. Like in previous video, we have discussed about substitution method, how to apply that. So initially I'll take this T of n is equal to 2t n by 2 plus C of n as equation 1. Now n by 2. So I'll calculate T of n by 2 here. Because here 2t n by 2 is there. No, so this for this sub element n by 2 I'll calculate what is the T of n. What would be the recurrence relation? So it would be 2t of n by 4 plus C of n by 2. Now this I'll substitute it in the first equation. So I'll get T of n is equal to 2 would be outside, inner part 2t n by 4 plus C of n by 2 plus C of n. So solving this further, I can write it as 4t of n by 4 plus C into 2n. So here I have n by 4 now. So let me write for t of n by 4. So for t of n by 4, it will be 2t of n by 8 plus C into n by 4. This I'll substitute here. So I would get T of n value as 2 cube T, because 4 again 2. So it will be 2 cube T here n by 8 plus C into 3n. So if this keeps on repeating, I would reach by obeying the trend here, by looking at the trend here, for ith element, let me write. I can get T of n is equal to 2 power I T of n by 2 power I plus C into I into n. Okay, C times I times n. So this is for the ith element. Now I'll consider this n by 2i and I'll take it as 1. In this case, n value I'll get it as 2 power I, and I value would be written as log to the base 2 n, log into the base 2. So I also know that T of 1 value is 0 here. T of 1 value is 0 here. So let me write for the expression here. That is, I have 2 power I. What is 2 power I value? N. Right. Plus C into I value. What is I value? Log n to the base 2 into n, because I have n here. So this n value would become 0 because t of 1 is 0, right? So here it will be 0. So 0 plus here I have c into n into log 2 base n. Log into the base 2. So I can write the time complexity as theta of n log n to the base 2. So this is the time complexity for the substitution by using the substitution method for merge sort. Further I can write, in total I can write this obeys for the worst case also, this is the same for average case also, and this goes the same for the best case also. So for the worst case I'll have big O, and for average I'll have theta, and for the best case I'll have omega. So this was about merge sort. We have done the analysis part, we have understood the algorithm, and we have also gone through an example. If you have any doubts regarding merge sort or this topic, do let me know in the comments.